Okay, so next on the agenda, we have the introductory presentation from Jim Duarte. So,
well, I really appreciate the confidence in the organization for inducting me into the International Academy. I feel humbled to be a member among all these folks that I've listened to and shared ideas with over the years, and I appreciate that. My background is in high school, I focused on academics, athletics, drama, and debate. Drama and debate helped me with being able to present and communicate well, and debate gave me a very good background in how to do research, which has helped me throughout my career. Academically in college, I have got a bachelor's and master's in statistics, which was very good. It was from Brigham Young University, which Brigham Young had an interesting program in the 60s and 70s with a bachelor's and master's, totally applied. So my background is in applied statistics, and that's they have a very, very high rate of employment from their master's program because of the applications emphasis in the program. When I departed college, I went into pharmaceuticals, clinical trials, and then when the good manufacturing practices came along, I was recruited to work on the good manufacturing practices and ended up on the statistics committee for the Pharmaceutical Manufacturers Association, along with that work to spread that information across pharmaceutical companies. I was recruited away from pharmaceuticals into metals, heavy industry, and did significant work there in using SPC and designed experiments for significant cost savings with my company, and ended up chairing a committee on statistical procedures for the Aluminum Association because we had several conflicts with the major metals companies dominating the standards process. And interestingly enough, when they dominated the standards process, their metals were the ones that met the standards. So we got an independent committee put together on statistical procedures to help with that. And then I got to work with a gentleman named Greg Watson at Hewlett-Packard as we started our total quality control effort there. And we had a gentleman from Japan that helped us significantly, Dr. Noriaki Kano, and he was a good influence on Greg and me at HP as we learned about the total quality. My achievements that I cherish the most are my 9 analytical patents. Worked with some great people, worked with an excellent petroleum engineer and an excellent geophysicist, and provided the analytical background for 9 patents in oil and gas. And that was really a major accomplishment that I'm very proud of, is that we were able to do that. We were able to get our patents worldwide. We have our patents in Hong Kong, Mexico, the UK, Canada, Norway, and China. So that's kind of my background. I'm married with 2 daughters. My first wife passed, and I remarried to a woman with 2 sons. So I've got perspective from both sides there. And on the social side, I like golf. Did like travel, and hopefully that will come back soon, and doing things with my family. So that's my my personal background, and hopefully that gives you an idea of some of the things I've done lately. I've done a lot until this COVID thing. I did a lot of international travel. Got to work with Dr. Su in Taiwan. Did some work in Qatar and Portugal. So it's been a fun route. To talk about my my interest at this time, I've done lots of things over the years. Taught SPC, was a Baldrige examiner, did whole lots of things. But right now I'm looking at data science. With the expansion of data and big data, what I'm seeing is that management really doesn't understand what data science is completely. And I feel that, on a second note, quality people have not really been embraced as people to collaborate on that topic, whereas we have the most knowledge in processes and products. And I think we have a very big contribution to make to this. And so I'd like to give you some information on how I see this and how we might be able to help move this forward. So we're into the 4.0 culture, industry 4.0, manufacturing 4.0, and we've even brought in quality 4.0, and it's playing a catch-up in the areas of digital transformation and analytics. So in digital transformation, we've got a lot of things going on with connected devices, tons of data, and I think that historically we've done sampling, and I think we need to reevaluate that and see what we can do to do more with data analysis on a larger scale and using more advanced analytics. For those of you who heard me speak in Shanghai or in Lisbon, one of the things that I've done with machine learning is look at ways to look at reducing the number of variables by analytically finding the highest contributors, which can reduce the size of a dashboard to the highest contributing variables and make dashboards more meaningful in many cases. And the second thing that it does is we know that a designed experiment is only as good as the variables that are in it. And so by reducing the number of variables to the key variables, you can see which variables would be the best to put into a designed experiment. And you've probably seen my examples of the peeling coating on cookware. So that's what I'd like to talk about now, is how we in Quality 4.0 and as quality leaders can move into the areas of digital transformation and analytics. So digital transformation, we're talking about things, we've talked to years about going paperless, having connected devices, driverless cars, AI, various kinds of things, and the cloud is really big now. And I think that we have in many cases, a misunderstanding of the cloud. Back in the day when we had mainframes, mainframe computers, I know that when I worked at a large metals company, we had a mainframe where all of our plants uploaded data every night. And this was back in the 80s. And they uploaded their data every night into the mainframe. So in that instance, the mainframe was like a cloud for our company, where we shared data, we shared software, and we did the same kind of things, not with a high degree of technology that we have today, but we had a cloud type of computing capability back in the mainframe days. So one of the observations I have with data is that we often don't look at the front end. We grab data, we analyze it, but we need to understand that it needs to be properly collected, cleansed, stored, formatted, and more importantly, be accessible to people. People need to be able to access the data to use it so that our decisions are more consistent and not just hoarding data. We have so many systems where we hoard data, but we don't do much with it. And sometimes that's because it wasn't stored properly, or it's not clean, or we can't get to it, or it's not formatted for the software we need. So this is very important that we look at the front end of the data. So then we need to abolish some previous stereotypes of quality people. We're not just inspectors. We're not just policy enforcers. We're not just documentation experts. And we're not just quality estimators. We need to be able to integrate data science into quality and the 4.0 culture, so that when we start talking about industry 4.0, quality 4.0, and these things, how do we integrate quality 4.0 and bring it up to the same level as what we see with our engineers and people in those production areas? So we need to expand our thinking and expand our knowledge and capabilities with data science. So this is something that Greg put into Quality Progress back last year about Quality 4.0 and all the rapid advancements. And he talked about far-fetched fantasies, and they're not fantasies anymore. I know I took a whole semester of sampling in graduate school. I don't use it much anymore because I have whole populations at my fingertips in data warehouses. So the thing is, you can't analyze data you can't get to, but you also need to ask yourself, what do you need? What data do you need and where is it? Is it clean? Is it formatted? So when we're thinking about these things, we need to ask ourselves about that and not just settle for localized data that we get from sampling, but if it's out there, what do we need? Do we know where it is? Have we talked to IT people? Do we know that it's clean? And is it formatted so that we can put it into software, whether it's closed source or open source software? How's it formatted? So when we look at analytics, there's IT versus OT, where IT is information technology, is usually the administrative side of the computer world. It handles accounting and sales and marketing and purchasing. And then there's OT, operational technology. Those are the computer folks that handle the connected devices. They handle information coming off of sensors, artificial intelligence, robotics. So we need to see which group handles which data and how we need it so that we can use it more effectively to solve quality problems. So there's technology everywhere, and data that is in the cloud or computing in the cloud. We need to understand those things. We don't have to be experts, but we need to understand what's going on. So now I like to use the 5 stages of analytical maturity and how we fit into this activity. I've been on the dais with Tom Davenport. I worked with Gene Harris at Accenture. So I know these people and I really like what they've written up. So when we look at these 5 stages of analytical maturity, first, analytically impaired. That's where organizations are data rich, but information poor. It's like the data is hoarded, but they don't know what to do with it. Stage 2, localized data. Six Sigma projects are a good example of localized data, localized control charts from sampling, not using whole data warehouses. And then we have stage 3, where the light comes on, executives want to commit to analytics, so what they do is they delegate it to IT. So they think that IT is the organization that should be leading this analytical activity, when in fact, that's really not their strength. We as quality professionals have more analytical capabilities than many IT people have. If they move to stage 4, this is where they start hiring what they call data scientists. And the data scientists then that they hire are model builders in most cases. They look at it as advanced modeling, and they don't look at the big picture of data science. So they hire data scientists, or if someone comes to management and says, I need a head count for a data scientist, management just says, okay. But I'm going to show you that there are really 4 categories of data science, and they should ask, what is it that you want this data scientist to do? And then stage 5 is where they actually understand the data science value chain. And I'm going to show you what that value chain looks like. So as we go through these stages, stage 1 is, what might this data tell us? We got all this out there. What can we find if we actually dig into it? Stage 2, localized. We've seen that. For example, in DMAIC, we've seen localized data with sampling, and people are just looking at what's in their little area. Stage 3, where it's given to IT, and management seems to believe that all things data belong to IT. And so IT, the people who have the budget and the personnel, feel obligated to answer management's questions. And really, business intelligence reports and queries are the norm for those people. They do a lot of things with reports and charts and graphs, but when it comes to deep analytics, expecting that from IT is really unfair. They're not trained to do that. So that's something that we need to look at. If management's just throwing it over the wall to IT, it's really unfair. And that's why the people come back and say, well, do you believe in magic? Because they really aren't trained to do the big, deep analytics. So what I propose with people is that we go from throwing it over the wall to a collaborative discussion. And the collaborative discussion then involves many areas of the organization. So we bring in engineering, we bring in sales, marketing, we bring in HR, we bring in all the people that have data that we need to look at. So now when we start expanding our view of the 4.0 culture, quality should be one of those contributors, a major contributor, because we understand the most about products and processes. And then by adding more perspectives and analytical capabilities, we need to ask ourselves, where do we fit? How do we fit into this? How do we show our value with Quality 4.0 and integrating that with Industry 4.0, Manufacturing 4.0? How do we integrate that, and how do we play a major role? Because we have a large knowledge base to contribute. How do we do that, and where do we fit? So now, I've kind of said this, but I want to make it concise. The quality professionals possess more of the tools than many of the other employees, especially the insights we have on processes and products to help make more consistent and better decisions with management. So how do we do that? So I had proposed in a paper in the Software Quality Professionals Journal back in June of last year called Data Science and the Quality Professional. In that article, I described 4 types of data scientists. One is the strategist, and that's your computer science expert. They're the ones that do the collection, the cleansing, the formatting, the giving the access. They're the front end. They're kind of like the suppliers. We have supplier quality activities. So with our supplier quality activities, we need to look at the same thing for data. What's our supplier quality for data? Second is the person who spans all the boundaries with advanced analytics. They basically work with all parts of the organization doing advanced analytics, and they have the tools of a statistician or other advanced capabilities, and they span the boundaries of the organization. Then the third group is the applications ninja. They're the ones who go out and are business analysts. They're the ones who take this information and go out and apply it to different areas. The fourth is the storyteller. These are the people that validate the report so that when management gets the information, it's correct, and the storyteller is making sure that the stories that are used for making decisions are valid and accurate. So really, data science has 4 roles, from highly technical computer down to communications capabilities, everywhere in between. And what I propose for quality people is look at where you fit. And I doubt many of us would fit into category 1, being a heavy-duty computer scientist. But we fit well into 3 and 4, and if we like and get the training, we could fit into category 2. So what I'm asking people to do for Quality 4.0 is look at where you can make a contribution and where with a little bit or a lot of education, you can help build better roles for data science. So now I found some information that says that the sexiest job of the 21st century is the data scientist. And it requires a multiple of disciplinary skills. So if we look at this and we look at the 4 categories, I have not found a person yet that can do all 4. So we've got the 4 categories here fit the 4 areas that I just described for data scientists. And if we think about it, today, quality professionals fit into these 2 categories, fit well. We're passionate about the business. We're curious about data. We can influence people without authority by showing data and looking at things, and we're big problem solvers. And we're able to engage with senior management and tell stories about what the data show us. We're very visual. We can handle many software packages, from PC packages all the way up through bigger software packages. So quality professionals now can fit into these 2 categories of a data scientist. Now, when we start adding math, statistics, and other things, quality professionals for the future in Quality 4.0 can learn statistical modeling, machine learning. We already do designed experiments. We do some Bayesian work. We look at a lot of unsupervised learning, cluster analysis, dimensionality reduction. We do a lot of that already. So just expanding our background, we fit, again, like I said in the last slide, there are 3 areas of data science that quality professionals fit into well. We just need to find people who are interested in these pieces and help them expand out their Quality 4.0 working in background. So if we look at a supply chain for manufacturing, we go anywhere, all the way from the supplier down to the customer. But what happens if we cut out the supplier? If we cut out the supplier and we don't look at the quality of the supply coming in, it really affects the whole supply chain process, which is why I say that is so important in data, that we look at the supply. Are the data clean, well formatted, properly collected, and accessible? So that's my parallel, is if we cut out the supplier and don't worry about what's going on with the supplier in a manufacturing process, we're in big trouble. And I think it's the same with data. So now I'm proposing a data science value chain. And this value chain that I'm proposing starts with at the bottom center, management has a question. They want to know more. They want to make better decisions. So they ask questions. People look at those questions. Why do people want to know this? Where are the data? What do we have? And then they move that into up to the left side to the data acquisition area. Where are the data? In the databases, online repositories, are they from web servers? Where are they? So now we have someone looking at data acquisition. Then the data preparation, getting it cleansed, transformed, and ready for analysis. In the top center, we have the exploratory, which, as we heard earlier, Bob talking about the great dashboards that we can put together. So those are very good tools for exploring the data and seeing what patterns we've got. Fits very well into the measure phase of DMAIC and partly into the analysis phase. And then we move over to data modeling, the heavy duty stuff, the heavy lifting. We start building models with machine learning or decision trees or different kinds of things. Then that comes down to then, how do we take that and put it into a visualization? Is it a dashboard? Is it another methodology to visualize what we found from the data? And then deploying that and maintaining those systems so that we can use those over and over again, and then continue through this data science value chain. So when we think about a value chain for manufacturing or other processes, we have the same kind of pattern here for the value chain for data science. I proposed a paper for the World Conference on what's rattling your data science value chain. Hopefully we can get this information in front of the World Conference for ASQ next year. So now I gave you 4 categories of data scientists. How do they fit here? So now if we look at where they fit, we see the strategist up there in the data preparation part, making sure that the supply of data is a good data supply, that it's done right. And then the boundary spanner that starts looking at exploring the data and modeling it and actually working with the analytics for the data. Then the applications ninjas, they're the ones that build the visualizations and apply it across the organization and help people understand what analytics can do for them, and then working with the storyteller to deploy and maintain that so that we properly communicate it and we get it to senior management in a way that they can utilize it for better decision making. So now a little bit more about analytics. For those of you who are not familiar with the terms of supervised and unsupervised analysis, I don't want to insult your intelligence, but if you're not familiar, I'll briefly describe that. Supervised analysis is where you're trying to predict something, like a regression analysis. So supervised analysis has a prediction variable that you're trying to get information about. So you've got many predictor variables trying to predict something. That's supervised analysis. Unsupervised is you're just looking for patterns, cluster analysis, principal components, those kinds of things where you're looking at patterns. So unsupervised analysis would be things like a Pareto chart, those kinds of things where you're not building a predictive model, you're just looking for patterns. And then the third piece is analytics at the edge. This is very important. Analytics at the edge is really easy to understand, but people make it very complicated because they have territory to protect. Really, analytics at the edge is a predictive model that controls an activity. When you think of driving your car and you push on the gas, how does the engine know how much gasoline to put in the engine to give you the speed that you need? Well, under the hood is a chip, and that chip has a predictive model built in it that takes in your RPMs, your speed, your tire pressure. All those variables of your car go into this predictive model that's in this chip, and it then determines the fuel flow to your engine. That chip is at the edge. That is analytics at the edge. So you have a chip at the edge under your hood controlling the activity. Grocery stores in the United States at checkout, when we're purchasing our groceries and we get our receipt, the receipt in many cases has coupons printed on the back. And those coupons are associated with things that we buy often so that we will come back to that grocery store. That's analytics at the edge. As that person is putting in what we buy, it's going into a predictive model that comes back and says, oh, this is what we predict this person will need in the next trip. And we're going to give them coupons to bring them back to get more business by using a predictive model that then gives the coupons at the edge of the purchase for the next visit. The third one is associated with the patents that I've worked on with the petroleum engineer and the geophysicist, where we looked at the penetration rate of an oil rig drilling in an oil or gas well. And we want to minimize the probability of breaking a drill bit, say 1,000 meters below the surface of the earth. We don't want to break a drill. It's very expensive to repair. So we built predictive models taking data from the drilling process to minimize the probability of breaking a drill and controlling the speed and the penetration rate at which that drill goes through rock or soft dirt, and being able to use the information from the geology to then determine how fast that's going to move. And we, like I said, we've had that accepted in many countries. So at the Berlin conference in 2017, the ASQ's European Quality Conference, I proposed 7 newer tools for Quality 4.0, and I modified it just slightly this year. So I combined predictive models and machine learning into one tool, a supervised tool, as I said, for doing predictions. And network diagrams, which I showed in Lisbon at the meetings, if you were there, showed how the network diagram can substitute for one network diagram can substitute for several Pareto diagrams. Cluster analysis, there are new tools there that make it visualized so you don't have to do scatter plots. You have a different way to look at those. Text analysis, 85% of today's data is in text. It's in free form, and that's very important. And we have ways of looking at that and doing things like disambiguation, which means like Paris Hilton walked into the Paris Hilton. Which is which is the hotel and which is the person. And there are tools that actually can differentiate between things like that and take away the ambiguity. Discrete event simulation, which is just queuing theory, which then we can take our value stream maps and we can put them into discrete event simulation and do what Goldratt taught us about theory of constraints and finding constraints quantitatively through simulation. Event stream processing is taking data that's coming at rapid rates off of sensors and processing it in a ways that I call control charts on steroids. basically signal to noise analysis, which is what a control chart is, and taking the random noise in a process and being in nanosecond time frames, finding signals in the data. So you're taking data that's coming through, not having to take samples of size X, but being able to use all of that data and finding the signals in the random noise. And number 7 is one I added this year, which is the Sankey diagram, which shows flow rates in processes. And you can see how many objects, for example, flowed through a rework station, how many flowed through different parts of the process, and you can actually see the volume of what's going through the system. So those are the 7 tools I proposed, again, in Berlin in 17, and modifying it now with the Sankey diagram this year. So really, to summarize, we really need to get people to understand we're more than inspectors, policy enforcers, documentation experts, and quality estimators. We're more than that. We did a lot of that historically, but with Quality 4.0, we don't want Quality 4.0 to leave people behind. We need to educate management on data science, and the role we can play in each of those 4 categories. We need to make our data wants and needs known so that we can improve decision making. We really need to get involved in that stage 3 of analytical maturity. It's not just IT. We need to communicate with IT. We need to learn some of the language and be able to communicate. Like I tell students when I've lectured at the universities, I say, make friends with your IT major, your friends that are majoring in IT. Take them out, buy them pizza and beer, and become their friends. The IT people are the people that will supply you with data. Because when you're in a class in a university and you go through an analytical module, what does the professor do? The professor says, okay, you have a homework assignment, and here's the link to the data. In the real world, you're not going to be given a link to clean data. You're going to have to understand the supply chain part of that and how that data gets collected, cleansed, formatted, and accessible. So you need to be able to get involved in that stage 3 so that management doesn't just give everything to IT and expect magic to happen. Show IT what you know about data science and the data science value chain. Show them that you are interested and you know about the different steps there. And then create projects that utilize the new analytical methods. You can always look at your projects and say, well, my project really could just use sampling data locally, but really there's a lot of data out there, and I would really like to have my project be able to use new tools and more data. And if you can do that, and then going back to making your wants and needs known, you can improve the decision making. And that's a big piece of where we can, as quality professionals, make a large impact on organizations. So what I'd like to give you now is the last 3 papers that I've published, just so you have that. So the number 3 one is the Data Science and Quality Professional, which describes in detail what data scientists can do and how quality professionals can actually fit into those categories. So I thank you for listening to me, and hopefully you'll consider that the role that we play in the 4.0 culture and how we can become more valuable to our organizations.
Thank you, Jim. And you certainly want to look in the chat box to see all of the good comments that are in there. We have just a couple of minutes for questions or comments before we move on to the next topic. Sunil, I see that you were interested in making a comment, and then after Sunil, we'll go to Pedro.
So, Jim, first of all, thank you very much for a wonderful presentation. And you kind of, you have shown a mirror to quality professionals and also a pathway on where to go in future. Do you agree with the probably the statement that the rate of change in quality world is yet to catch up with the rate of change in the digital world, and probably quality 4.0, what you have, the way you have explained, um, doesn't have a very well formed, accepted contours and definition, and I'm saying internationally, not on one or two forums, and probably its infantile stage of development. There is a confusion on how to integrate with rapidly advancing digital technology, which is further accelerated due to COVID. So, uh, do you have any thoughts on further thoughts on how to democratize this quality 4.0, how to redefine the role of quality professionals so that we do not lose out sitting on the high table where the new discussions on digitalization and strategy is taking place? Because one more thing that I observe is the traditional vocabulary of quality is slowly disappearing from the Fortune 500 companies. I may have made statements which are probably a little provocative. I'm not sure whether you agree with this or not. Over to you, Jim.
You've just given me an opportunity to swing my banner for Quality 4.0. I agree with you that we are not moving as fast as we could. One of the things that excited me most about the humbling experience of being inducted into the International Academy is being able to speak with so many people across the world, and the possibility of putting together activities within the Academy that may do exactly what you're suggesting. How do we do that? Do we have a way to bring our collective knowledge together to build that definition and build that pathway for the future? So what I proposed in this presentation was to open people's eyes, give them the incentive to actually do what you suggest. Yes, I have ideas, but I'm one voice in the wilderness, where in fact I'd like to be able to be in the forest of trees of academicians, where we can build a forest that will grow exactly what you're describing. It is my vision to be able to present this information to more and more people and get people on board with assisting and expanding our ideas on how to do that, because you are right. I'm doing some work with the Shanghai Academy in integrating some of this with digital transformation methodologies and putting total quality and integrating that with digital transformation. But I have the benefit of having worked with a software company where I saw the whole spectrum of data science, and saw as a quality professional for decades where we have so many opportunities, but we just don't understand. It's like we don't know what we don't know. And I'm trying to get us to, we now know what we don't know. So now how do we educate ourselves and move forward?
Okay, thank you. And Pedro, you had a comment or a question?
Yes, Jim, thanks for a great presentation and this new concept of the data science value chain, which I think is a good evolution from the previous thoughts you had on the topic. And that's pretty much where I'd like to focus some comments, because I think we have to never underestimate that data quality is a big issue. And we have been strong contributors to metrology, so I think we need to think what will be the equivalent for metrology concepts when you're dealing with big data, because now I'm the dean of a data science school, and we have lots of projects, but I'd say 50% of the effort is assuring that you have strong data quality to begin with. And I think quality professionals can play a role also in that particular field. It's not just IT that is going to assure that you have data quality as your raw material. And then on the other end of the cycle, I have also a minor comment. I think reinforcing that you need to make decisions, otherwise you don't generate value. So you can just going through an infinite loop where everyone is happy. You see the big data going around, but not too much happens, because there is a lack of decisions inspired by data. And then sometimes I'd say with big data, it's not just the management asking the right question and you go after the answer. Data can give you insights on what the question should be. So this is something that I'd like also eventually to comment, because sometimes really data will inspire you to get the right questions, and you can get suggestions for what the right questions may be if you use properly the big data approaches that now we have available. So these are just two minor thoughts to complement a wonderful presentation.
Thank you for your kind comments. Yes, you're absolutely right. And I understand what you're saying. So in that diagram I have, I need to put a better emphasis on that final spot about decision making, because we all know that in the first statistics class that we take, we learn about hypothesis testing, we get to the final stage, and we say whether we can reject the hypothesis or not, and the class stops there. Stat 1 classes, they never go past whether they can accept the hypothesis, whether they can reject the hypothesis or not, and then so what? We never get to the so what of rejecting or not rejecting the hypothesis. And the students are left with, okay, I learned how to do this, what good is it? And you're absolutely right.
Okay, thank you. Were there any last comments?
May I?
Dr. Cano, yes, and then we'll move on after your comments.
So, Jim, thank you very much. Very interesting presentation. So now, my question is very simple. You talk about that, say, in slide number 7, you talk about that. Is it clean? You ask me, so it means that, say, you have the idea which data is clean, which data is dirty. So that is my very interesting point. In this situation, the reason is that, say, when I have that, I have the big data analysis, I'm always saying, I will understand that it is when you talk about the case of that economic or social data, so on. But the problem is that, say, today, many plants have a very huge data, very big data. But the data is completely different from social data. It is particularly the company which has a very good quality control. They have the standardization, standardized and very well controlled. So in this situation, if you take the correlation, usually no correlation, that is very fine. Correlation means that some problem like this. It's very different from that the usual big data like this. So in this case, I'm wondering, when you talk about that the cream, in this case, you're talking about such a standardized data or something else, or what do you mean by dirty? So that is my point. So that could you give me the idea? Thank you.
So clean data, what we mean is that there is consistency in the records. And then when we do the analysis, to your point, in the analysis, we find out if there are conflicts or correlations. Clean data means that the records are consistent and we don't have duplicate information or misspellings. So you're right with the standardized data in manufacturing, and we've done that very well. What we're looking at is when the data is coming to the user, are the records consistent? So if we have records that, for example, in the social area, and we're talking about people, and I'm in the database as Jim Duarte and James Duarte and James E. Duarte, And cleaning the data means that all three of those are the same person, and we need to get that consolidated. So part of the cleansing process is consolidating to accurate records that we can then analyze to get to the second point, which is then, after we've analyzed it, now how do we standardize it and make it standard? But we can't go to standardization until we have consistent, clean records.
This is just my comment. That when you talk about this in the case that I think that the data which is generated under the concept of PDCA, including standardization, and then the data which are not say under the say PDCA, even though it's a consistent what you mentioned, it's a completely, I think, quite a big difference. I think if you have such kind of clarification, I think it will be for the quality expert viewpoint who has who would say we understand very much about the data and the standardization so on. That can be more easily accessed to this big data. Thank you.
Back to you, Liz.